Welcome you to this virtual Welcome to Cal State Fullerton Day, the Mechanical Engineering session. I am Chen Jingo. I am the department chair for the department. So what we're going to do today is we are going to first give a brief presentations about 15 to 20 minutes. And then after the presentation, you get to send in your questions through the chat feature. And our mechanical engineering faculty joining us today will address those questions. So joining us this afternoon, we have Dr. Hope Weiss.
Hello.
And also Dr. Justin Tran.
Hello.
Okay, so we are going to start with the presentation. So what we are going to do in terms of this presentation today is I am going to give you the resources that you can find from our website. Okay, so this is the web address for our mechanical engineering website. Okay, and it is very easy to find if you go to the Cal State Fullerton front page. If you use the A through Z index, and you can click E for engineering, and then you should be able to find the mechanical engineering website from that link. Or you can remember this web address as well. So as an incoming freshman or a transfer student, now one of the most important things that you need to look into is the mechanical engineering degree flowchart. And this is available in the front page of the mechanical engineering website. Okay, so if you click on that, you can download the PDF version of this flowchart. Okay, so this flowchart is a 4-year degree roadmap for our undergraduate students. So as you can see that we require 120 units. And from this flowchart, you can see the courses that we recommend students to take in each semester of their degree programs. Okay, so I'm not going to go over this flowchart in detail today. Normally, I do that during the freshman orientations. So if you decide to join Cal State Fullerton, you will be attending the freshman orientation very soon in the summer. And at that time, I will go over this flowchart in detail. In mechanical engineering, we have 14 full-time faculty. So these are the full-time faculty that we have in the department. We also have part-time faculty coming from the industry. We have part-time faculty from Boeing, Raytheon, Edwards Life Science, Marathon Petroleum. So these are some of the companies that they are coming from. So our faculty, they are very diverse. And we have faculty in different expertise of mechanical engineering. And from our website, you can also get a lot of useful advising resources. So for example, you can find a lot of frequently asked questions. How should you plan your general education classes? Okay, how to contact advisors, for example. These type of informations are available from our website. And if you look into that undergraduate advising resources, you are going to find out that for our undergraduate advisors, for freshmen and sophomores, We have retention specialists. We have college advisors from the ECS Student Success Center, handling the advising for our freshmen and sophomores. So, and this is the contact email address for the ECS Student Success Center. So as an incoming freshman, you are going to work with these advisors in your first 2 years. As for juniors and seniors, as well as transfer students, we have mechanical engineering faculty handling the advising. So Dr. Hope Weiss and Professor Eric Stacy, these are the 2 undergraduate advisors that we have in the department. And if you have any questions for the mechanical engineering advisor, the email address is given here. The next thing that I'm going to do is, I'm going to show some video clips for the senior design projects. Okay. Normally we get about 30 to 35 projects per year. Okay. We have the legacy projects. Okay. The legacy projects are projects that we have every year. So some of the examples for our legacy projects, the Titan Racing Formula, Titan Racing Baja, Rover, the Aero, the UAV project. So these are some of our legacy projects that we have every year. In addition to that, we also have projects from our sponsor partners. So this academic year, we have projects from Bristol, we have projects from Disney, and we have projects from Edwards. So I'm going to show some of these video clips for the projects. So the first video that I'm going to show is our formula project.
Titan Racing is the official chapter for our university for the Society of Automotive Engineers, or as we just call it, SAE. So when you do Formula SAE, what you're really learning is you are taking what they have taught you in the classroom and you're applying it to a practical real-life scenario. Now on Formula SAE, we are trying to make like a smaller scale of a Formula One car and bring it out to a competition where we race it in a few different what we call dynamic events. So it'll have a straight line acceleration event, and then it'll have another event that involves a lot of twists and turns that we call autocross. And finally, it'll compete in an endurance event where we'll have to run this car for 22 kilometers without anything failing. We've gone from making just a simple frame that could house an engine and a powertrain that could physically compete to continuously making improvements and finding different, better materials that we can use to make these cars. And over the years, we've gained so many sponsorships and so much, support from different organizations and companies that we've actually been able to make some big changes to the car, such as we now have a carbon fiber driver cell that we use, which wouldn't be possible without all the connections that we've been able to make. And we in the past couple of years have made a motor swap, so we are now using a newer higher displacement motor than what we've been using before. And of course the development of an aero package, which we were not able to do until about 3 years ago. The team's goal for this year's competition is to try to become a top 10 team at competition, right? To show a lot of the other universities that Cal State Fullerton is definitely, one of the more prominent schools in the competition. Titan Racing is the official chapter for our university for the Society of Automotive Engineers.
So that was the first project, the Formula Racing. And I'm going to show the next project, the Baja project.
When the
So these are the two core projects that we have, okay? And the next video clip that I'm going to show is the Titan Rover project, another senior design project that we have. So as you are watching this video, so when you have any questions, okay, please start sending your questions through the chat feature, okay? So after watching the videos, then the mechanical engineering faculty will address your questions. So I'm going to go and show you the Rover project.
Justin McGregor, the president and project lead for Titan Rover. Titan Rover is a two-part organization, an educational club and a URC design team with overlap between the two. The club's purpose is to inspire students to reach higher in space exploration and STEM education by using our past URC rovers and robotics demonstrations. The design team sets out to design and manufacture a complete rover for the URC. We now have 2 years of competition behind us and have learned some valuable lessons along the way. Last year, we developed Atlas from the ground up. This gave us a robust mechanical platform to work with, and we decided to make iterative changes this year and focus on the areas of opportunity we found through the analysis of our past performance. I am proud to introduce to you Calypso, based on the Atlas platform.
Beyond the lessons we learned from last year's competition, we decided to put the mechanical system through a series of rigorous tests to determine key locations for weight reduction to increase rover functionality. Testing provided valuable information, verifying that our system is robust enough to tackle any difficult terrain that is featured at competition.
Dual brush DC motors are mounted into each custom hub assembly in order to shield them from rocks. The tires have a custom tread design in order to increase our traversal abilities across sand, dirt, as well as steep slopes. We have prototyped and are currently testing a semi-active suspension system, which allows us to change the ride height and suspension settings at any time.
Using software provided by our sponsor Altium, we are designing a PCB that will shut off any subsystem that is drawing too much current. In addition, we have a physical kill switch with dual circuit control using an internal solenoid. This allows us to physically cut all power to the rover, as well as send a remote command to depower the mobility system in the event of an undesired movement.
The robotic arm is designed for both form and function. It features 5 degrees of freedom and utilizes carbon fiber limbs that act as structural members while acting as an internal channel for all cabling and drive systems.
Feedback is designed into every joint of the robotic arm to enable real-time position of the arm and allow the use of inverse kinematics. The gripper can accommodate a vast array of objects using specialized gripper tips to maximize the points of contact on many standard and oddly shaped objects. The gripper can be field swapped for other types of end effectors if needed. The major joints and components of the arm have been designed with manufacturability and weight reduction in mind. Quick release connectors for electrical and mechanical connections allow for easy serviceability during assembly and maintenance.
During the autonomous task, the rover is going to leverage the onboard processing cores in NVIDIA's Jetson TX2. We're utilizing both the GPU and the ARM processor on the computer vision system. We have built a custom model in TensorFlow for the tennis ball detection. Using machine learning, the model has accurately identified the tennis ball up to 16 feet away. Our navigation platform is based on a simultaneous localization and mapping model within the robotic operating system. Our sensors will construct an environment in which the rover will operate. After reaching the provided GPS point, a mathematical algorithm will create a search pattern based off of known system and vision constraints. This will include any prior obstacles that the rover has encountered and added to the slant model.
Our sensor package uses a 2-dimensional LiDAR unit, a centimeter-accurate GNSS, and an IMU. These components allow us to continuously update our position within our SLAM model. The LiDAR is mapping the terrain, while the GNSS is localizing the position. By choosing Python in a module design pattern, we're able to seamlessly integrate these sensors to conduct unit testing and authenticate software verification and validation.
For this year's science system, we have refocused our efforts on collecting a suitable sample for our life detection assays. This involved designing a hollow stem auger that is able to collect and store a sample down to a depth of 10 inches while preserving relative superposition. In addition, our suite of sensors measures atmospheric variables such as barometric pressure, air temperature and humidity, UV radiation, wind speed, and CO2 abundance. Our in situ soil probe measures soil moisture and subsurface temperature. Our custom user interface logs and graphs the data from the sensors both on board and back at the base station, as well as records photos and video through our various camera systems. Our biochemical lab analysis consists of several tests to directly observe biologic organisms. Slide staining and UV spectroscopy will give us information on cell morphology, cell component structure, presence of genetic material, and endospore production. We will characterize the sample's chemical environment using pH testing and cation-anion identification.
Titan Rover continues to push the boundaries through rigorous testing and constant refinement. Thanks for watching, and I'll see you in Utah.
Okay, before I show the last video, I just want to remind all of you to send in your questions as we are watching the last video clip. Okay, so the last video that I'm going to show, this is from our Aero project.
A group of 6 engineering students have taken on an ambitious senior design project, building an aerial drone.
It's an unmanned aerial system that's capable of either autonomous or manual control. What it does is it will fly, it'll take off and land by itself, fly a pre-selected routine, and also target ID.
As part of Project Orca, Operation Reconnaissance and Canvassing Aircraft, the drone will be put to the test in the Student Unmanned Aerial Vehicle Competition at the Naval Air Station Patuxent River in Maryland. The drone will identify targets on the ground by using the students' original software system, a challenge for the competition.
And so we want to do something new and
We thought UAVs are big and they're becoming a big part of military work.
The ethics of drone use were considered in the students' design and functionality.
One of the major things that we had to address in the senior design class was actually the social and political implications of building a drone like this. And so, we really had to think about who is going to be using it, what are they going to be using it for, what is our responsibility as far as being designers of technology that could potentially be helpful or harmful, and how to kind of, I guess, keep control of that and make sure that it was used in a positive way.
Hart Russell from the College of Engineering and Computer Science believes competitions such as Project Orca and other high-impact learning opportunities are important elements in students' educational growth.
The student design project and the collegiate design projects give students an opportunity to demonstrate what they've learned, but also from the university perspective, we have the opportunity to send our students out to demonstrate the value of our program. So the students are ambassadors not only for their own professional development, but they're also ambassadors regarding the quality of the program. And so we're actually thankful that the students are willing to engage in these kinds of activities and do so on behalf of the university.
We had collaborators that would sit with us and meet with us about our design. They would have a lot of input. We had people from Boeing and Swift and Raytheon out putting input and saying, hey, you should work on this. Don't forget about this. Don't forget about that. And it taught us how to communicate with those types of people, because those aren't entry-level engineers, those are managers, those are people that you need to talk to in industry when you get out there.
Just understanding what it takes to make a team bring an entire plane together has just been amazing.
For more information on the College of Engineering and Computer Science at Cal State Fullerton, visit www.fullerton.edu/ECS.
Okay, so those 4 video clips that you just watched, these are considered as our legacy projects, okay, for the senior design students. So we have these legacy projects every year, okay. As you can see that they are very interdisciplinary, they are very practical. Our students are having the opportunity to implement and apply what they learn in all these required classes in the degree program to these project in their last year. Okay, so now after working on these projects, now they are going to be prepared for the industry. For example, the Titan Aero project that you just watched, that was from 2013. Okay, the team members on that particular project, now Diana Jones, she's currently working for Raytheon. Michael Strager, he is currently working for JPL. Jake Bailey, he's working for Raytheon in Arizona as well, and he's also a PhD student in the University of Arizona. So these are some of the senior design projects that we have. And finally, this is the contact information for the Mechanical Engineering Department. So you can get this contact information from our website as well. So you have the email address and the phone number given here. So with that, now we are going to address the questions that you have sent in. So if you haven't sent in your questions, now would be the time to send in your question, so that we have 2 other mechanical engineering faculty here. Dr. Hope Weiss is also our undergraduate advisor. We can help you with the questions that you may have. So as an incoming freshman, in your first 2 years, okay, you are going to pay a lot of attention, and you are going to study very hard in your math and science classes, okay? These are very important classes that you need, as these are the foundation for the engineering classes that you are going to get into. So please make sure that you do that in your math and science classes. And also advising is very important. And in fact, advising is mandatory for mechanical engineering majors. So we require our students to meet with the advisor at least one time per year. Because we want our students to know the degree requirements very well, to ensure them that they are on track with their degree program, to ensure that they are taking the right classes now. And also our advisors are helping our students to address any questions that you may have throughout the degree program. So once again, for incoming freshmen, the advisors from the ECS Student Success Center will be advising you, okay? And for transfer students, you may want to get in touch with the mechanical engineering advisors so that we know, what classes will be transferred over from your community college, and also what classes you need to take for this coming fall. So that's why it is very important for you to know the degree program by looking at the flowchart, okay? And of course, now for all of the incoming freshmen and also the transfer students, now we get to address all of this during the orientation in the summer. So any questions?